We are talking about two sample hypothesis testing, but this time we're talking about paired samples, and we're also going to talk about confidence intervals when you're finding the confidence interval for the difference in two population parameters, and we're going to be using our Rguroo again. So what do I mean by paired samples? So let's look at the following scenario. A mechanic wants to know if a tune-up will improve gas mileage. The mileage in miles per gallon was found for each of 8 automobiles. The mileage for each vehicle was found a second time after a tune-up was given. The table below shows the mileage for each car before and after the tune-up. So usually what happens for paired data is that basically we take the same sample twice. From our population, we get two types of data from it. So each individual, each unit in the population has two data numbers. So one for the first sample, one for the second. So you see we have before tune-up and then gas mileage after tune-up. And so they're paired for each car. Right? So these, again, these are paired samples because each value before tune-up is paired with a value from the same car after tune-up. And what we want to do is we want to determine if the population mean mileage is higher after the tune-up. So the first thing that happens when you do this test is you are running a two population mean inference. And you're using the t statistic, so it's a two sample mean test with a t statistic. But in order to do it, technically you need to find the differences in the paired values. So you would subtract each one of these. Now that obviously takes a while, but our Rguroo will do all of that for you, so you don't have to worry about actually finding the differences. So then what you would say is for the null, you would say there's no difference. Kind of like what we were saying before, we would say in the past when we did two sample tests, we would say for the null, we would say mu1 equals mu2, and that would imply that there's no difference. Now, the way you write it for a paired test is a little bit different. Instead of writing mu1 is equal to mu2, you would write mu_d, standing for the mean difference is equal to 0, because if you were to subtract the 2, and you would get 0, that means there's no difference. So why do we write it this way? So before, you would take all the means of, or you would take the overall mean of one population and the overall mean of the other, and if there's no difference, they should equal. Here, what we're doing is we are taking the average difference. We're taking the difference first and then averaging them, and we're saying the average of the differences should be 0, implying that the overall population average of the differences would be 0 if there's no difference. So you would write mu with a little d here, a lowercase d, equals 0. And for the alternate statement, we'd write mu d is less than, greater than, or equal to 0. So this is your H0. This one of these three is your H1 or your HA. So that is a difference. That's a difference in the way we write it. So be really careful when it's paired. You're supposed to write it this way. So the steps are pretty much the same with a few minor differences. The first difference is the way we write our null and our alternate statement. You do need to create your data set of your before and after data, or however they're paired. And then you're going to choose a mean inference, 1 and 2 population, just like we did for the other 2 sample tests that we did on a previous video. You will this time you're going to choose the data set. And then you're going to choose the 2 variables. Choose the data set, the 2 variables. And then the biggest difference here is we have to click paired. There's a paired box that I told you in previous videos to leave alone. This time we're going to check paired because they are paired. And then you're going to move over to the population 1-2 tab for the hypothesis testing. You're going to enter the significance level, your H1, and your test statistic preview. If you would like to do a confidence interval, you can click the confidence interval tab and include that as well. And then, as always, compare the p-value to significance level, reject or fail to reject the null, write the conclusion in context of each one. And there you have it. So lots and lots of similarities to all the hypothesis testing we've done in the past. A few differences. The way we write the null and the alternate, it's still the same. Equality for H0, inequality for H1, but some of the mechanics of it looks a little bit different. And then the other thing is just making sure you type in that data set and save it into Rguroo first. Let me show you what the boxes look like. So you've seen these boxes before, and in the past, we filled out the population 1 and 2. But what happens is you would click your data set and then choose your two variables. And then once you click paired, this changes from population 1 to paired difference. And it's going to show the subtraction of variable 1 minus variable 2. And it'll give the sample mean of the difference, the sample standard deviation of the difference, and then the sample size. It's going to give you all that. Then you'll skip over and click population 1, 2, and you will include your significance level, your alternate hypothesis less than, greater than, or not equal to, and it's, of course, can be 0. We will choose T statistic again because you know the sample standard deviation of the difference, not the population standard deviation. And then this will already be checked because you checked it on the previous, on the summary screen. If you forgot to click it on the summary screen, you can click it here. Okay, and then preview, and that's it. I mean, if you want to do confidence interval, you can click confidence interval and add in your confidence level and then T statistic. But most of the test looks pretty much the same, just like I said, a few minor differences. So let's look at this same problem. Example 1, tune-up. A mechanic wants to know if a tune-up will improve gas mileage. The mileage in miles per gallon was found for each of 8 automobiles. The mileage for each vehicle was found a second time after a tune-up was given. The table above shows the mileage for each car before and after the tune-up. Can you conclude that tune-ups improve mileage? So here is what we're trying to conclude. All right. And I can see the data is paired because I've got 2 sets of data for 8 cars. So this is paired data. So I can go ahead and write for my null that the mean difference is 0. And for the alternate, I'm going to say that the mean difference, if it improves, that means you get more miles after the tune-up. So if I did after minus before, and after should be greater because you would get more miles per gallon. So we would do greater. All right. There we have that. Okay, so let's go back and relearn how to put in a data set. So if you are, oops, that's the wrong thing. That's my YouTube channel. Okay, here we go. So we would go to the data tab, data import, and you would do create new data set. So for every variable, so we have after tune-up, you would type in after tune-up, and then you would add, that's one column, and you would add a second column by clicking here, and you would type in before tune-up. And then to add rows, you click this button, and there were 8 cars. So you would click it until there were 8 rows. Oops, and I accidentally clicked too many, so I'm going to click this button to delete the row. And then you double click here until you see the little cursor flashing, and then you type in the first number, 35.44, and then don't hit enter, hit the down arrow. Okay, and then you would do that same thing with the before tune-up, and in between each number you click the down arrow, and then you would save it as something like gas mileage. Okay, so I'm going to go back here to this screen, and you pause the video and you enter the data. Okay, so hopefully you pause the video. We are going to go to, sorry, I'm keep clicking the wrong things here. I've got so many windows open. I'm going to close this out because I actually already put this in. It's somewhere in here. Let me just look it up. I'm going to type in gas mileage. Okay, so let me show you something cool. When you do this, I want gas mileage. That's what I called it, right? So when I go to run the test, I'm going to go to analytics and analysis, and I'm going to do a mean inference 1-2 population. So then because I searched it here and that's what's up, when I go to select data set, there's only one data set. I don't have to scroll through all of them, and I can just click here. So gas mileage, and then I want to subtract after tune-up minus before tune-up. So it's really important that you get the order right. So after minus before, and then I'm going to click paired here, paired. And so let me uncheck it. See, you have population 1 and population 2. And now when I click paired, it's just a paired difference. We're going to skip over to population 1, 2. The significance level is 0.01. So if I did a confidence level, it'd be 0.99. I'm going to click T statistic. Again, you don't have to do the confidence interval, but I would like to. Significance level we said was 0.01, and we're saying that the after tune-up should be greater than the before, so the difference will be greater than 0. T statistic, make sure paired data is checked. So again, choose your data set, choose your two variables in the correct order that you would want to subtract them that would agree with your alternate hypothesis statement. In the summary, click paired, and everything should pop up there. Click population 1, 2. Enter your confidence level and T-stat if you want to do a confidence interval, and then enter your significance level, your alternate hypothesis, and T-statistic if you're doing the hypothesis test, which we are. Don't forget to make sure paired is checked, and then preview. All right, so I am writing this down. You guys write it down too. What's cool is you can see we've got the after tune-up, before tune-up, and then the difference here. Right? So I'm going to go ahead and write the confidence interval for later. The confidence interval is between 0.7445 and 1.668. Just for future reference, they're both positive. If I scroll, I can see the p-value is, in scientific notation, it's 1.92514 E negative 5. And so let me go back here. And what that means is we move that decimal 1, 2, 3, 4, 5 places to the left. When you move it 5 places to the left, it means you add 4 zeros between the decimal and the first non-zero digit. So we've got a p-value of 0.000019, which is definitely less than any significance level that we would probably come up with. It's definitely less than 0.01. So we are going to reject the null. And if we reject the null, we can support H1. So we need to write that out. There is enough evidence to conclude that, and I'm just going to copy this part here because this is the same as saying H1, that tune-ups improve mileage. You could also say there's enough evidence to conclude that the mean difference in gas mileage is greater after tune-ups. Also, let's look at the confidence interval. So we would say something like, we are 99% confident that the mean difference of gas mileage before and the mean difference of gas mileage after tune-up and gas mileage before tune-up is between 0.7445 and 1.668. And what does that mean? What does that mean? So they're both positive, so that implies that the mean difference is greater than 0. So if that's greater than 0, it implies that it is greater. So that is what we concluded. We concluded that it was greater because the gas mileage has improved, so it agrees. Okay, so real quick before I go into any more, I wanted to let you know that I have shared this all of the data sets for the examples in this particular lecture. I have shared them on Rguroo. Let me find Rguroo. Okay, so if you would like to import these data sets that I've shared, you're going to go to My Groups and click on Show My Groups. If you have not joined my group, then join my group. And then you're going to click on your class and you're going to see my repositories that I've shared with you. So this one is called Paired Tests. And then here are all of the data sets for all of the examples. So there's even the one we just did, gas mileage. There's one called cholesterol, reaction times, brake pads, dominant hand, gas mileage, and hypnotism. So whichever ones you want, you just click. And if you hit control click, you can click all of them at the same time. And then you would hit import data sets. And then they would pop up over here under data sets. Okay. All right. Moving on to the next example. Brake pads. So if you want, you could do one of two things before we get started on this one. You can go and you can add this data set. You can pause the video and add the data set, or you can go ahead, pause the video and import all of the data sets for this lecture now so that you can go ahead and have that done and out of the way. And unpause when you're done, and we will get into example 2. All right. Example 2, brake pads. For a sample of 9 automobiles, the mileage in thousands of miles at which the original front brake pads were worn to 10% of their original thickness was measured, as was the mileage at which the original rear brake pads were worn to 10% of their original thickness. The results are given below. Can you conclude that the mean time for rear brake pads to wear out is longer than the mean time for front pads? Use a 0.05 significance level. So this is definitely paired data because you've got rear and front for each of 9. All right, so this is definitely paired. So we're going to say for the null that the mean difference is 0. And for the alternate, we're trying to conclude that the mean time for rear brake pads to wear out is longer than those of front brake pads. So if I do the mean difference of rear minus front, because you want rear brake pads to be greater. So rear minus front for the difference would be greater than 0. So that's important. So rear brake pads will be the first variable and front will be the second variable. Okay. All right, let's go to Rguroo. All right, I'm going to go ahead. So to make this short, I'm going to type in brake pads. All right, so I've got that up, brake pads. And then I'm going to go to analytics and I'm choosing mean inference 1-2 population. I'm going to select my data set, brake pads, and then variable 1 we said has to be rear, variable 2 has to be front. And then we want to pair it. So click paired. So again, brake pads, variable 1 is rear, front, and then paired. And then go to population 1-2 if you want to do a confidence interval. 95 goes with 0.05, significance level, t-statistic, test hypothesis, 0.05, and we want it to wear out is longer. So the mileage would be longer, so the mileage would be greater here. So you hit greater than 0 t-statistic. So again, because we did rear first, rear minus front, rear is greater, so it would be greater than 0. If we had did front and then rear, you'd have to do less than 0 because front would be less than the rear. Okay, so be careful in the order you put it here, and you make sure that this symbol matches up with what you're trying to say. All right, and then preview. All right, so on my other screen that you can't see, I'm writing down my confidence interval, which is 10 point, I'm just going to round it to one decimal place, 10.1 to 10.9, and then a p-value, another scientific notation, p-value of 3.19 e to the negative 12. So that's very, very small. And rather than move the decimal, all of those places to the left, I'm just going to say that's around 0, if we round that to 0. So that is definitely less than 0.05. So we're going to reject the null. And if we reject the null, that means there is enough evidence to conclude that the mean time for rear brake pads to wear out is longer than the mean time for front brake pads. Whew. And then if you were writing a sentence for your confidence interval, you'd say we're 95% confident that the mean difference in the time it takes to wear out, the mean difference in the time for rear brake pads to wear out and the mean time of front pads to wear out is between 10.1 and 10.9. So what does this mean? Again, don't worry about the numbers themselves. Worry about the signs. So it is positive. So positive implies that it is greater. Two positives implies greater. So that is what we're saying here, that it's longer, which would be greater. So this agrees. All right, hypnotism. So again, pause the video if you need to type in the data. If you've already got the data set from, imported it from where I shared it with a group, then don't worry about it. Okay, example 3. A study was conducted to investigate the effectiveness of hypnotism in reducing pain. Results for randomly selected subjects are shown below. A lower score indicates less pain. The before value is matched up to an after value, and the differences are calculated. The differences have a normal distribution. Are the sensory measurements on average lower after hypnotism? So we want after to be lower. So you want to put in after and then before. Actually, you can do it either way. You just want variable 1 to be after and variable 2 to be before. So you can type it in before then after or after then before. It's just when you run the test, make sure you choose after as your first, because we're saying after is the one that's lower. So that one has to go first. All right. So I'm going to go here and type in hypnotism. Now you don't have to do this part if you've already got it. It's just if you type this in here to have this come up, then when we run the test, the mean inference test, and I go to choose my data set, you don't see all of your data sets. And for me, I have I don't know, at least 50 data sets. So rather than trying to scroll and find it, this is a quick way to get it. So hypnotism to reduce pain. And remember, the first variable has to be after, and the second variable has to be before. And the reason is because after needs to be less than before. So after minus before should be less than 0. So make sure it goes in that order. Click paired after minus before. That's correct. Population, confidence interval, 5%, so 95% here. T statistic, test hypothesis, we're going to do lower, so then 0. So it's 0 every time there. Hit T-stat, make sure paired is chosen, and here we go. So we're writing down a couple things. We're writing down our confidence interval, so negative 5.6 to negative 0.7, and then a p-value of 0.0095. There's the graph if you want to see it. Okay, so we never wrote down our null and our alternate statement, so let me go ahead and do that. The null is mu d equals 0 because it's paired, and the alternate is mu d is less than 0, and we're doing after minus before. And since the p-value is 0.009, that's less than 0.05 or 5%, so we're going to reject the null. So we would say, oops, apologize, I clicked the wrong button there. We would say there is enough evidence to conclude the sensory measurements on average are lower after hypnotism. And then if we were going to write a sentence to go with our confidence interval, we would say we are 95% confident that the mean difference in pain levels after hypnotism and pain levels before hypnotism are between negative 5.6 and negative 0.07. And what that means is they're both negative, so that implies the mean difference is less than 0. And that's what we concluded, that it's lower after hypnotism, so it agrees with what we found. All right. Cholesterol. So pause the video, enter the data if you need to. All right. Hopefully you entered the data. If not, do that right now. So a study was conducted to investigate how effective a new diet was in lowering cholesterol. Results for a randomly selected subject are shown in the table. The differences have a normal distribution. Are subjects' cholesterol levels lower on average after the diet? So lower after. So we need to do after minus before. So variables 1 and 2, because it's got to be lower after, and if we're doing lower, we're going to do less than. So whichever one has to be less than, that one goes first. So hopefully you entered the data. I'm going to go ahead and write my null and alternate because I forgot, I think, last time. So mu d equals 0, and we're saying it's lower. So we're doing less than. Okay. All right, so going over here, I'm going to type in my data set, which is called cholesterol. So that's up and under analysis, mean inference, 1 and 2 population, data set cholesterol, pair. Oops, I got to hit the variables first. So variable 1 is after, and variable 1 is before, because we want after to be less. Now, we could do before first and after second, but then you would use the greater than sign for your alternate. Go to population 1, 2. We're doing 5% confidence. I'm sorry, significance levels. That's a 95% confidence level. T-stat, we're doing lower than 0. Again, T-stat, make sure paired is checked. Preview, we're writing down our confidence interval. Looks like we got 2 negatives. So negative 19.9 and negative 1.7, and our p-value is 0.0130. We've got a 5% significance level. And there's the graph if you want to see that. So we know that our significance level is less than 0.05. So we're going to reject the null. Rejecting this. That means we have enough evidence to support that claim, that H1. So we need to write it in context though. So there is enough evidence to conclude cholesterol levels are lower on average after the diet. And then for the confidence level or the confidence interval, we'd say we are 95% confident that the mean difference in cholesterol levels before and after the diet is between negative 19.9 and negative 1.7. And because they're both negative, it implies that the difference is lower than 0, which is what we found here. So it agrees. All right. One more dominant hand. You want to, you want to go ahead and enter this data set if you have not imported it from the group. So hit pause. All right, 5 ball players think they can throw the same distance with their dominant hand throwing and offhand catching hand. So we got throwing hand and catching hand. So the dominant hand is the throwing hand and the offhand is the catching hand. Conduct a hypothesis test to determine whether the mean difference in distances between the dominant and offhand is significant. Test at 5% level. So we're trying to see if there is a difference. So they don't really specify if the distance needs to be longer or shorter in either one. So because of that, we're just going to use this for our null and this for our alternate. They didn't specify, so we're just going to do not equal to 0. Okay, and then in that case, it doesn't matter which hand is variable 1 and variable 2. So I'm just going to go in order 1 and 2 like that. Okay, so going back to Rguroo. I don't remember how I saved this. I think I wrote dominant hand. Okay, so I've got dominant hand up here, analytics, analysis, mean inference, 1 and 2 population, and we're going to select dominant hands. Variable 1, it doesn't matter. I'm just going to go in order because we're doing not equal to as our alternate's a two-tailed, so it doesn't matter the order. Do paired population. And again, you don't have to do these confidence intervals and if they're not asked for, but I like to do it just to see how it compares. And we're doing not equal to this time. T statistic, as always, for these. All right, so we have a confidence level, or interval, rather, of negative 2.8 and 2. Oh, no, I'm writing down critical values. Confidence interval of 4.9 and 38.7, and a p-value of 0.023, 0. You want to see the graph? There they are. Going back to the screen, we're doing 5%, so this is less than 5%. So if it's less than 5%, we reject the null. So we would say there is, because we're rejecting this, so there is enough evidence for H1. So there is enough evidence to conclude the mean difference in distances between the dominant hand and offhand is significant. You could also say are different, because that's what we're concluding when we're agreeing with not equal to 0. For a confidence interval, we would say we are 95% confident that the mean difference in distances between dominant and offhand is between 4.9 and 38.7, meaning they're both positive, implying that the mean difference is greater than 0. If it's greater than 0, that means there is a difference. So it does agree. It does agree. So we're going to switch gears for a minute. We're just going to talk more about those confidence intervals for the differences in means and proportions and that paired data. So I've been doing the confidence intervals this whole time. So this is actually a section to kind of like summarize that and review that, because we've been doing the confidence intervals with pretty much every single example that we've done for 2 population testing. So just to remind you, if you were doing, let me, 2 population mean inference. If you were doing a 2 population mean inference, then what you're doing when you find the confidence interval for that is you're estimating the difference between the population means. And then if you were doing a 2 population proportion interval, you're estimating the difference in proportions, in the 2 population proportions. And then if you're doing a population mean, a 2 population mean inference, and the data is paired, you are estimating the mean difference of that paired data. Don't worry about this part here. Okay, so this is what you do need to know. If you were to write the interpretation sentence, you would say, we are 95% confident that the difference in the means or proportions is between blank and blank. Or you could say mean difference. And then this is just kind of a summary of what I had told you before. If you don't really look at the numbers, you look at the signs. If both signs are positive, it implies that there's no difference, right? I'm sorry, I said that wrong. If it's both positive, it implies that mean 1 is greater than mean 2. So it means that the mean difference is greater than 0 if you were doing the pair data. If you were doing the proportion data, it would mean that P1 is greater than P2. All right, and then if they're both negative, it implies that mu1 is less than mu2, or P1 is less than P2, or that the mean difference is less than 0. And if you've got a negative and a positive, it implies that the two means are equal, or the difference is equal to 0, that there's no difference, or that P1 is equal to P2. So that's just kind of reviewing what it is that we already covered when we did all of these confidence intervals. So there are 3 more examples, 1, 2, and 3, and these just cover finding the confidence interval. You're not actually doing the test, you're doing a confidence interval. I'm actually going to allow you to do those, and I will include the answers in the filled in notes. So when you look at that, you can check your answers here, here, and here, but I'm not going to go through them on the video since we've been doing confidence intervals this whole time, and I just wanted to review what they meant. So definitely practice the extra ones. You can even do, you could even run a test and see if the test agrees with the confidence interval that you found. So anyway, answer key, for example, 1, 2, and 3 for the confidence intervals in the difference in the two populations parameters will be in the filled in notes. Okay, so that is all I have for you today. If you have questions, let me know.